So as we've been working on proofs, which of course is some of our favorite things to do, right? We've been using direct proofs where we start with a true hypothesis and then we work to try to prove that the conclusion is also true. In this little chapter section, we're going to be talking about indirect reasoning or indirect proof. And indirect reasoning starts by assuming that the conclusion is false and then showing the assumption is a contradiction. So indirect proof, which is also called proof by contradiction or proof by negation, is that we temporarily, the first step is to take a hypothesis or a conclusion and assume that it is false. And then we use logical reasoning to show that the assumption leads to a contradiction of what we have reframed as a false statement. And if we prove that our statement that we made false is true, then we have proved the original statement. Got all that? All right, hopefully so. Now, what we do, though, is we start out by taking a statement and that we assume and we make, or should say, we make a false assumption out of it. So let's look at a couple of examples here algebraically, and then we'll go to geometrically a little bit later. So we're given a statement here that x is greater than 5. Now, in this example, which is on page 355 and the homework that would follow from it, we're just making we're stating an assumption to start an indirect proof. So we're going to take what is maybe a true statement and we're going to reframe it as a false statement. So the way we would reframe, let's say x is greater than 5, well, we could say that x is less than or equal to 5. So that's taking the original statement and then state an assumption that would be the opposite or false of that. Let's look at this second one here. Triangle XYZ is an equilateral triangle. Well, that's just simply a saying that triangle XYZ is not an equilateral triangle. Okay, that's all there is to this part of it. May get a little bit more complex as we move to writing an indirect proof and then moving over to indirect proofs with geometry, but hey, we're up for the task, right? Of course we are.